Hello everyone, welcome to the webinar. My name is Clarisse. I work here at iBwave in marketing and I will be your host today. So first of all, I hope everyone is well and safe during this unprecedented situation. Like it obviously needs adjustment from all of us, and I'm thankful to be able to conduct this webinar remotely. So we really hope you will enjoy the content we have to offer you today, as today's webinar topic is bridging macro and indoor challenges and key applications for campus networks. So I'm joined today by Dean Bubley to cover the key trends and challenges of indoor-outdoor design. And in the second part, Marc-Antoine Lamontagne from iBwave will introduce the new unified solution we are developing in collaboration with InfoVista. So before we get started, I just want to cover off a couple housekeeping items. So the webinar will be recorded and sent to everyone after the presentation in the next couple of days. And you're welcome to ask questions to our presenters by using the GoToWebinar question box. So now I'm going to hand the microphone off to Dean. Hello, Dean. Thanks for being with us today.
Thank you, Clarisse. Thank you. Hi, so I'm going to talk through for about the next 25-30 minutes, a little bit of background on campus networks, what they are, what the use cases are, what's going to change with 5G, but also with various other trends that are going on. And really understand why this sort of new category of radio environment is becoming more important, both for service providers, but also for building owners and enterprises. So as a quick introduction, I'm an industry analyst and consultant. I advise a variety of companies and governments on trends in technology, particularly wireless technologies, and also sort of voice. And I'm also a general futurist, so I look at the impact of changing businesses, economies, societies, and other adjacent technologies, which sort of play in, particularly around things like IoT, and I'll touch on that as I go through. So, the way I would look at it is, in the past, the traditional approach to sort of building, planning, and sort of in many ways the business models for cellular networks have been fundamentally different for the outdoor and indoor environment. And also, for completeness, I've included on this slide the rural and remote side of things, but I'm not going to be talking about that in depth today. And a lot of cellular licenses for spectrum actually stipulate coverage requirements, which is focused on primarily outdoor requirements. And yet, as we know, most users spend a significant proportion of their time in buildings, whether that's their home or maybe not at the moment offices, but in general, larger structures, whether that's an airport or a shopping mall or an office block or whatever. And the traditional approach in the industry to planning those networks has been very distinct, both from an economic point of view, but also because of the different stakeholders involved. In the outdoor environment, primarily, it's just the network operator and the end user. Whereas as soon as you look at the built environment, you have building owners, tenants, enterprises, variety of different stakeholders involved, and sometimes also the building management infrastructure, indoor wireless providers of various sorts, and I'll talk about neutral hosts a bit later as well. And what that's meant has been that we've got different economic models and often different tool sets used. Obviously, in building, you also have Wi-Fi and other technologies as well. And that distinction is going to change again in the 5G era. Now, I'll use this term 5G era because it's not just about 5G. There's a whole set of changes that are coming in terms of how companies use wireless technologies of different sorts, all roughly at the same time. And so wouldn't necessarily focus solely on 5G, but also think about everything else as private 4G and 5G. You've got a change in the way that networks are built with small cells and virtualized and cloud-based radio networks, evolution of Wi-Fi, Wi-Fi 6, new spectrum has just been announced in the US the last couple of days, mesh technologies. Going forward, you're also going to be thinking about things like network slicing, and TSN is time-sensitive networking, really oriented around the new classes of use case and user, which we can expect to be existing both indoors and outdoors in coming years. And also, I'll mention public safety, which is clearly an issue here as well. And that's evolving fast. You're seeing at the moment a lot of increasing emphasis on next generation of public safety capabilities, whether that's interactivity on, for example, augmented reality headsets, use of robotics, and various other things. So some of you who've seen my presentations before will recognize this slide or a variation of it. And as usual, I apologize for how simple this is. I could only get 6 dimensions out of about 15 onto a 2-dimensional page. And the point here is just to say there are so many different ways we're going to see wireless networks used, designed, built, owned, and the performance characteristics, the technologies used. Yes, we're talking primarily here about 5G and 4G, but also the wireless Wi-Fi iterations, but also in some cases we have to think about low power, wide area, even satellite networks as well. And I think from the coverage dimension I've got on this, I've put indoor and campus. One of the challenges we have is to start thinking about holistically from a user and application point of view. Where does network coverage need to be provided? How do we provide performance? And in some cases, how do we give SLAs and guarantees on that performance? And I'll highlight the importance axis here as well. At the moment, most usage focus of particularly cellular indoors essentially is people bringing their mobile phone into the building. And whilst there are clearly certain really important use cases for smartphone use indoors, a lot of them are maybe function critical, application critical. There's very few safety critical uses apart from calling for emergency, obviously. But as we look at IoT, and particularly in, say, industrial markets or medical or others, we're going to be calling on our wireless networks to do things which, frankly, could endanger someone's health or even life. Particularly if you think about industrial automation in a factory. And so then we have to really think carefully about what networks are available in what parts of the building with what performance criteria. And often that has to be not just indoors, but also the surrounding areas. So one of the things I'll highlight on that up front before I get into the specific use cases is you only have to look at the TV now to realize that an awful lot of hospitals around the world now have outdoor facilities as well. A lot of the tents that have been set up for receiving patients with suspected virus at the moment are set up in the parking lot, maybe a nearby park. So suddenly we have critical healthcare facilities in locations that we never expected. Whilst that's perhaps a one-off incident, it does really throw into stark light how this sort of outdoor-indoor duality perhaps is just a thing of the past. And so from a network point of view, planning point of view, in the 3G or 4G eras, when we've been designing and planning indoor wireless systems, primarily our main consideration has been how the outdoor macro network impacts on in the indoor environment. Is there outdoor to indoor penetration of and propagation? Can people just rely on the outdoor network, or what sort of indoor wireless system is required for different use cases and applications in parts of the building? There hasn't historically been an awful lot of interference indoor to outdoor, at least in part because they're primarily talking here about DAS systems and the like. And so there has historically been this sort of duality of development, planning, and operation for indoor and outdoor. This is changing in 2 ways in the 5G era. The first thing is that the outdoor macro networks are themselves getting more dense. We are seeing a lot of city center and urban infill sites. We're seeing small cells on lighting poles or utility poles or around the campus environments at different height levels. And so the problems of the outdoor to indoor have got significantly more complicated, and that's going to evolve even further with 5G when you start considering the spectrum bands that are being used, but particularly where you have beamforming and multiple antennas with MIMO. And so that's the outdoor to indoor. And at the same time, we have to think about the obverse as well, the indoor to outdoor, both deliberate and accidental. And we're seeing more indoor systems that will be using millimeter wave and also, less millimeter wave, more small cells, and in variety of frequency bands, which may well then themselves interact with the macro network. But also, as I'm going to be talking about over the next few slides, there's a lot of applications that need to work continuously over indoor and outdoor environments, which might be anchored indoors. And I know we've talked in the past about someone walking out the front door with a phone and switching over from the indoor network back to the macro network. But this gets much more complicated when we start talking about IoT. So it might be a truck leaving a warehouse. It could be a baggage handling trolley at an airport that's going from the luggage carousel area underneath the building out onto the airport campus. There's also connected to the side of the plane. There's a lot of indoor-outdoor hybrid use cases that are coming down the line. And to give you some ideas about this, it's probably worth starting to think about the vertical markets and the industries that have indoor and outdoor spaces and how their use is evolving, and what might happen when some of the 5G visions become more realistic in the future. So obviously urban cores where you've got transportation facilities, people coming out of metro stations, for example, people in parks, people in other covered spaces, who don't necessarily always make this distinction of indoor outdoor. And I think we're going to see, obviously not right at the moment, but in a more general normal state of affairs in the world, we can see a lot of requirements there for these sort of hybrid environments. Universities, obviously the term campus tends to get used, or historically was particularly focusing on education facilities and is now expanded semantically. But also education buildings also quite often have people working outside. They have requirements for everything from security to, again, public safety that spans the outdoor areas for recreation and for study and learning. Airports, as I've already mentioned, airports are interesting because you've got a real diversity of different types of facility. So you've got the terminal buildings, which often have the passenger areas, but also the back office and the catering and the baggage handling and security functions as well. But you also have maintenance buildings, you've got fuel dumps, and you've got a wide variety of parking areas and service areas outdoors as well. And increasingly, we'll see applications spanning all of those. Office developments, both sort of in inner city areas where you've got maybe a mixed use property development that's may have everything from tower blocks to parks to lakes, or you've got the equivalent in more low-rise Silicon Valley style office campuses or business parks, technology parks in a lot of places as well. One of the interesting things I'm seeing is also this sort of dichotomy of public and private space on the same facility. So I mentioned the hospital just now, but you only have to look at the number of buildings that now have rooftop gardens or bars. Is that part of the building? Is it indoors? Is it outdoors? Whose responsibility is that if it's on the 75th floor? And so I think there's a lot of interesting things that are going to go along in the public-private domain as well. And then on the industrial side, I've got ports and industrial plants, and these are obviously a major focus for 5G, where you're looking at perhaps private and campus area networks. Might be run by a service provider, it might be run by the port authority, it might be run by an industrial provider. And on previous webinars that I've done with iBwave, we've talked about in the US CBRS, but more generally private networks, whether that's 4G or 5G. There's a whole range of new spectrum options that are being made available in North America, in the UK, in Germany, in Japan, other countries. And we're seeing huge interest in everything from car manufacturers to port authorities to everything from industrial sites of oil and gas and mining facilities, which again are, some of those have some very challenging environments. So for example, in mining, you've obviously got both outdoors and sometimes you have tunnels and underground domains as well. When you've listened to this call, there's an ebook to download which goes into all this in more detail. But one thing I've put in the report is for a selection of these vertical industries, just to sort of enumerate the different indoor and outdoor areas. Here I've got airports, ports, logistics, and mixed-use property developments, but there's a bunch of others in there as well. And these are designed to help people think through the use cases, the requirements. Parking is a good one where you may have both covered parking and open parking, underground car parks as well. And as we think to the future, and we think about, say, connected vehicles in that example, are we going to have some sort of restriction which says autonomous vehicles must only park in the outdoor parking? I don't think that's a reasonable state of affairs. There will be an expectation of equivalent performance in different areas, and that's going to be true whether you have an autonomous or connected vehicle, whether you have automated guided vehicles for logistics that are essentially like automated forklift trucks, which could go indoors and outdoors. But also, for example, one of the things that talking about the current situation in the world is there are companies, for example, I know in China, and I would imagine soon elsewhere, that have disinfecting robots, and they can do outdoor areas, but obviously in, say, a hospital environment, there will be a strong need for them to operate indoors as well. And so those are the sorts of use cases which some of those are unpredictable, but we have to expect that there will need to be some sort of continuity of performance, particularly if it's backed by a service provider's service level of agreement, say for ultra reliable or low latency communications with 5G, that is doesn't distinguish between the indoor and outdoor environments. And so you can start looking at this from both supply and demand sides of things. There's a bunch of things that service providers, and I'll talk later about why the term service provider is itself a very wide term, things that they will want to do which impact on campus networks. And as I've said, 5G is a particularly important one, providing enterprise solutions. So actually, one of the things that's worth noting is that depending who you speak to, the term campus network means different things. So I'm using the term campus network here to mean indoor and outdoor hybrid environments. Some service providers I speak to talk about campus networks as just meaning private enterprise networks, which may just be one building in a factory. So I know, for example, Deutsche Telekom and Swisscom in Europe are both looking at campus networks, which don't necessarily include the outdoor areas as well. It's much more one of them terms for their solution aimed at particularly industrial customer base. What we're seeing, new spectrum and more spectrum choices, whether that's with carrier aggregation or what to do about millimeter wave. And millimeter wave is going to have a huge set of issues here of where on a campus it gets used. Do you want to have coverage indoors and outdoors? How you deal with that? How you deal with multi-operator coverage in that situation? And there clearly are going to be a lot of places where whilst there might be one service provider taking the lead, a retail environment or accommodation or hotels is realistically going to need to have good coverage for most or all of the service providers in that country, unless there's some sort of national roaming or neutral host model, which I'll talk about. I think that one interesting thing on campuses is some campuses are built in areas with traditionally no macro coverage. So if you think about a new hotel or a new business park that's made, 2 kilometers outside of a village, they may well on day one have very little macro coverage, as well as challenging new LEED compliant buildings with low E glass and perhaps even other forms of environmental shielding. I think they're also going to be looking at these sort of industrial markets as a key target. So again, the industrial perhaps processing industry where there's lots of metal work. Again, indoor and outdoor domains are quite complicated. We're also seeing from the regulatory side a whole set of new regulatory rules on spectrum. There's certainly more interest I see from regulators and governments in indoor coverage and I think that we'll see that ramp up given the current high levels of indoor demand we're seeing at the moment, not just in offices, but potentially residential as well. So there's a number of things. I talk about those in more depth in the report, but there's essentially, from a service provider point of view, a lot of reasons to start thinking about campuses. And then in terms of the venue owners themselves and enterprises, in some cases, they will want to have 5G for their own use cases, whether they're building their own network or going to a service provider. So you might have an industrial company, a factory or manufacturing environment where you might have multiple buildings, but you have AGVs delivering materials from one to the other, transiting an outside area for some distance, and also having to operate with full cloud control for safety reasons. There's going to be a demand both on the business aspects or industrial aspects, but also on from a consumer point of view in terms of application consistency across those domains. So it could well be there's going to be various new, could be augmented reality applications, wearables. We just don't know at the moment. But this artificial distinction between indoor and outdoor, from the venue owner point of view, imagine a resort owner. If you're, I don't know, a Disney or a large hotel chain, you want your customers to be able to get the same applications, the same experience, whether they're in their room or whether they're by the pool. I think another interesting thing here is that we're going to see more and more locations that are multiple industries in the same place. So mixed use property, you already get this, where you might have office space, hotels, retail, entertainment, all in the same venue. And there will be a hybrid of indoor and outdoor areas where you've got perhaps people working outdoors. You have maybe a recreation or food and beverage options that are on a terrace and so on. Another one that I think is going to be high on the agenda for many organizations is security. And I think that there's going to be a requirement for wireless connectivity for cameras and maybe security robots as well, which again, doesn't necessarily distinguish between indoor and outdoor environments. And the last one on there is 3D. In some cases, we are going to see more use of drones, whether that's for delivery of things or whether it's, again, security or various other functions. And I think that we have to start thinking about the outdoor areas in 3 dimensions as well as 2. And in terms of how big a deal all this is a slide I used to talk about private networks primarily. But what we could term campus scale networks pretty much are those that are in the maybe 500 meter to 5 kilometer range, and this is going to vary depending on the size of the airport. Clearly, some of the larger airports are bigger than that, and there are going to be some places which have multiple indoor and outdoor domains which are less than 500 meters. But to an approximate first case, that's not a bad way of looking at things. And that's where you've got things like hospital complexes, universities, industrial plants, ports and airports, business parks, even things like a music festival could come into that. And at the top end, this starts to get into the sort of smart city environment and mining and some oil and gas facilities, although some of those can actually be very extensive indeed. Another lens to look at this through is the user classes that may apply. And this is something which I think is interesting to look at, because historically we've mostly thought about smartphone use and where do people go holding their phones. Maybe for Wi-Fi, obviously you've got PCs and tablets, but increasingly we're going to have a whole class of new connected devices that may either be moving or static in areas that we don't always think about. For example, you're going to have what I'll refer to here as mobile IoT. And so vehicles and AGVs of various sorts are important. Could be security, could be moving materials around, could be vehicles, cars and so on. But you also have things like payment handhelds and various bits of portable equipment. Again, if you think about a hospital environment, you may well find that you have patients walking with some sort of sensor or piece of equipment, or it's put on a trolley and just wheeled around by the staff. So I think that we have to sort of start thinking more about these other classes of product, and they may have some particularly unique requirements. So for example, if you've got cameras, obviously uplink is more important, displays, the opposite is true. And then industrial automation and sensors may well have very, very tight latency requirements or deterministic network requirements that have specific linkages through to the future with network slicing and what we see in 3GPP release 16, 17, 18. And the last couple of points on this are the local tenants and roaming neutral hosts. This I'll talk about in a few minutes again about the business models, but often there's may well be a chain of different service providers here. So you may well find that the airport authority is running a private network and their customers are B2B customers, so the catering company, the fuel companies, the logistics companies, and almost you have in that case the venue owner acting as a service provider in their own right, may even have local MVNOs as well, which brings a whole additional set of complexity. And I think one of the things we also like to see is more roaming and sharing models. We see this in the US with CBRS networks, where I was on a call last week with someone that wants essentially the service providers to roam onto their network when their users come in building, and that has all sorts of interesting implications in terms of whose responsibility it is to design and to test and to operate those. One thing I'll flag here is it's not obvious at this stage which direction campuses will evolve from. Whether you'll find very, very localized application-specific networks, for example, machine vision for a particular machine in a factory or a particular security camera use case in one facility, and then expand to cover a whole building and then the plant and campus, or whether you might see the opposite true. So you might find that a port deploys an open air network to cover the dockside and the ships and the shipping containers, and then fills in the warehouses and offices as a secondary part of that afterwards. So I think we'll see sort of both directions of evolution here, going from campus down to micro coverage concerns in building or specific applications, or going the other way. So I've made a couple of comments already about business model, and I think that it's worth highlighting what I see as sort of three main classes of campus networks here, which will overlap in various complicated ways as well. And so probably the most obvious one is a single mobile network operator that's running it as a network on a campus, perhaps for a large enterprise, where they are the primary service provider. They've perhaps done a corporate deal with a large company which has multiple buildings on site to give both the coverage for their employees, perhaps the various vehicles, and so on. And they build out a network optimized for themselves across multiple indoor and outdoor areas, and then maybe invite the other service providers on later on. Then we're going to have the private campus networks, and this is more the industrial model, but it could also be a hotel or resort. Again, it's dependent a little bit on spectrum and some of the things I talked about on the CBRS webinar a few months ago, and its equivalents around the world. And this may well be run by the enterprise themselves, or it could be an industrial specialist operator of one form or another that could come from an large automation or IT vendor or a cloud company. And they may have either a requirement just for their own use, or they may also want to have mobile operators connectivity to roam onto or share various parts of that network. And there's lots of sort of technical approaches there, which I won't go into here. And the last one is the shared and neutral host model, which has been around for a while, but I see becoming much more important now and much more ambitious. A number of major companies are in this space with large amounts of financial backing. There's a lot of M&A that's gone on between fiber companies, tower companies, existing in-building players, coupled with innovations around virtualized RAN and open RAN. I think that's one of the most interesting parts of the entire wireless industry at the moment. I do quite a lot of work on neutral host models, and whilst in-building is one area, I'm also seeing them used for metropolitan areas along road and rail side, and this type of hybrid campus environment I think will be important, where you'll see maybe property companies look to either run or commission their own networks, and then look to invite service for other service providers to roam or share afterwards. And that may well work on a more property-based investment model, where you can imagine if someone's building a new business park, they put the infrastructure in as capex up front, and then look to amortize that over a very long period. And that may be a very different economic horizon to a private campus network or MNOs. One slide which I think is important to put in. What's the impact of the coronavirus on this? Now, to be honest, this is a slide I'm trying to put into all of my decks at the moment and everything I write about, because clearly pretty much any document we wrote or forecast we made more than a month and a half ago is now pretty obsolete. My view, and I did a long call on coronavirus impact on telecoms generally yesterday, is it's still very early days and there's a lot of variables. We don't know. Firstly, we don't know how the virus is going to be treated and whether we're still all in lockdown in 3 months or 6 months' time. But more beyond that, I think we don't know what the economic fallout of that is going to be, and it's likely to vary by sector, by country. We're seeing existing networks that are holding up, but their capacity may well be in the wrong places. So at the moment, there's a lot of networks in urban areas and shopping malls and along highways and so forth, but that's not where people are using their devices at the moment. I think you'll see some industries that will obviously be ahead of the curve and some behind the curve in the longer term. I think we'll see more focus on government, healthcare, utility and logistics sites, a lot of focus on the supply chain at the moment. Perhaps a bit of slightly less focus on airports, shopping malls, hotels and sports. That's in the short term. Maybe on a 1, 2, 3 year view, everything bounces back, but that's going to be very national. And I've got a number of scenarios I'm looking at. And under some conditions, you may actually find that there's going to be some accelerated transformation in some of those sectors, where in fact that when they bounce back, particularly if there's been perhaps a change of ownership because of financial problems, that we may well see more of a focus on everything from network infrastructure to improve climate modeling and climate and CO2 emissions through to the operations in next generation factories and airports, which are perhaps more designed to reduce levels of human contact and improve automation. I think we're going to be moving to a world, and this is more of a macro level, where we start seeing a focus on, rather than on just in time everywhere, it'll be just in case. And we may well see more government push to stress tests and look at performance for connectivity, indoor, outdoor, for different industries. And there's some interesting potential regulatory changes to come over the next few years as well. So just to wrap up my last slide, my view, and I've said this on a couple of other contexts, is that 5G is really driving transformation of telecoms top to bottom. And I think that the 4G era of not just what the structure of the industry looks like, but how we design networks and this binary choice of indoor and outdoor is going to really change, and it's going to change in different ways in different sectors, different building types. It may all come along at the same time as new classes of service provider as well. So I'm already seeing certain industrial groups that are looking at running their own networks. We're seeing more military and public safety networks, transportation, whether that's wide area on road or rail, or whether it's hub sites like ports and airports. And so I think that we will see the campus concept, and whether you call it campus or mid-size area or other terms, become a lot more important, particularly when you consider the use cases around IoT and the business models around neutral host sharing, or for that matter, traditional MNOs looking at providing enterprise solutions with their 5G networks. And with that, I will hand over to Marc-Antoine.
All right, so let me just share my screen. Oops. This one, okay. Okay, thank you, Dean. That was a very informative session. Thanks for that. So in my section, I wanted to give you a quick overview about a new product that we're working on called iBwave Reach. So this is kind of a follow-up since we've done a press announcement of the collaboration with Infovista. So today on the call, I'll take the time to give you a quick overview about this. So my name is Marc-Antoine Lamontagne. I've been with iBwave for the last 10 years, and I've taken the role lately as a solution director for OEMs. Okay, so what we are talking about here is that we are collaborating with Infovista, so iBwave and Infovista, on an integrated solution to design both macro and indoor. So Infovista has been one of the leader for macro design wireless, very successful for the past 10-15 years, and iBwave is the leader as well for in-building design as well. So we've decided to collaborate as we see the industry moving more into a very dense environment where it becomes imperative to bridge the gap between indoor and outdoor. You see it more and more with the deployments that we see on 5G, where the density of the network is growing. You see a lot of cells deployed in between the macro and the in-building layers, and it becomes more and more challenging to keep the complete network fully functional and so on. So we decided to join forces to leverage our combined experience and leadership to create a joint solution for our customers. So what I'm going to share today is a little bit more details about iBwave Reach, which is the first materialization of our solution between iBwave and Infovista. So this has been in the work for many months already, and we are including representatives from the industry through POC activities where we test out our solution and to make sure that we address the right challenges with our solution as we come out with a GA product. So a little bit more details about Reach. So iBwave Reach basically is a new application that offer design capability for a campus environment or for the surrounding outdoor environment of an in-building network. So it's a new application, and it works jointly with iBwave Design Full Suite to give you the ability to design both indoor and outdoor in a seamless way and clearly understand the impact of one network on the other. So if we look at this in more details, if we take the use case of a campus network, what you can you'll be able to do is to use iBwave Reach, which is basically an OEM version of Planet focused on campus environment. So if you take the campus environment that you see here, what you can do is with Reach, you can design from the macro environment. So you can model the macro environment around the campus, and then you can add outdoor cells on the outdoor environment of the campus, and then use the application to completely model and optimize that portion of the network. Once you are okay with this portion of the design, then you can seamlessly switch to iBwave Design. So we've defined a very easy way and seamless way to give access to iBwave Design to all the outdoor prediction and interference inside the building. So when you do your in-building design, you have access to the current coverage of the macro network inside the building, considering the wall environment and material. So you can optimize this design for indoor, and then you can switch back after you are done with the in-building design back to iBwave Reach, where you're gonna see the leakage of the in-building system out on the outdoor environment. So once you have that visibility, then you can make sure that your outdoor design is still valid. And if that's not the case, then you can take the time to optimize that network and then finalize your design. So by connecting the two applications, you have everything you need to create in a seamless way a complete design that include your indoor environment and your outdoor environment, and then combine the output of both tools to generate a design package. So one use case that we can share here is basically the use case of one of our customers. So it is a tier 1 operator in Canada, and their challenge was to design urban buildings. So for an urban building, what they typically do is they go on site to perform a site walk to measure the current penetration of the macro network. And then once they collect that for a few floors, then they can start the in-building design and consider the macro as they do their design. But this method is quite costly. It's a few $1,000s every time for every project to get this measurement activity done. And also sometime it delays the project because you need security clearance to get access to the building, and it adds delays to your project. So and furthermore, when you talk about greenfield building, they don't currently have a solution. So what they typically do will be to take some pessimistic assumptions when it comes to the macro network penetration, which typically lead to over designing the solution. So by using iBwave Reach combined with iBwave Design, they see that they can completely eliminate site walks pre-design and replace that with macro prediction around the building that they typically have already available on their side. So basically it accelerates the process. It reduces cost of the survey, but also in the case of greenfield buildings, it can also reduce the cost of the equipment to deploy the solution. And then lastly, for them, it's a question of being also less disruptive for their customers. So furthermore to this use case, with our iBwave Reach solution, we target to address a long list of use cases all around campus network where you need to design both for indoor and outdoor solutions. So the first two are basically the urban building, either an existing or a greenfield building, so very similar to what I've just discussed earlier. But then you have all the campus type of environment, shopping malls, healthcare, hospitality, airports, campuses, and amusement park. So those are typically designed today using iBwave design, but with many challenges to do so. And it's very difficult to design the complete environment as one project and make sure that once you deploy, you have the right performance expected. So the idea with iBwave Reach would be to design all of those use cases as one network and reduce afterwards the extra cost that you typically need to do today in optimization to basically ensure a sweet interaction between the two layers in indoor and outdoor. Then you have the use cases of enterprise networks. So certainly you have CBRS in the US, but you can think of local 5G in Japan and many other countries with specific bands and blocks allocated for private networks. So iBwave Reach provides a solution to design this type of enterprise network, many times including indoor and outdoor environment, and design that seamlessly. And then lastly, another use case that we are targeting with this solution is the energy market as well. One example of that is a mine. We have a proof of concept with a mine right now. It's an outdoor mine, and they are looking at using autonomous trucks in the mine. So this has been very tedious to design. So iBwave Reach comes as a much easier solution to design this type of environment in a more seamless and interesting way. So overall, you have some time and cost savings benefits definitely for the design of large campus environment by removing the survey step in your process, but also increasing the quality of your design by integrating the indoor and the outdoor environment as part of the same design, and have a view very seamless of the interaction of one network over the other. So a lot of the optimization now can be done at the design level instead of doing it in the field, which costs a lot more. Another important point is that we are building this solution jointly with Infovista, but the solution is agnostic of the macro tool that you are using. So if you are using competitors of Infovista Planet, like Atoll or Asset, you're still going to be able to benefit from the solution by simply remodeling the macro environment from the configuration in the macro tool, and then model the complete campus environment using iBwave Reach and iBwave Design. And then it really adds a new layer on iBwave Design to enhance the capability for 5G and HetNet densification, and really have a better way of integrating the indoor and the outdoor as you do your designs. So this is a quick sneak peek of what we are working on. The solution is still being worked on, but we are progressing rapidly on that. We'll have more sessions where we're going to have some live demos and more details about the concrete solution. So at this point of the call, I guess Clarisse will take some questions from the audience.
Yes, thank you very much, Marc. We're gonna take some questions. The first one I have for you, maybe on iBwave, is iBwave working on a tool that enables to view indoor and outdoor predictions on the same layout?
Yes, so as I presented today, basically the solution combines iBwave Reach and iBwave Design to do a complete campus. But what's important to say is that once you bring back the prediction in iBwave Reach, you're also going to be able to display the complete prediction for the campus by combining the outdoor prediction and the indoor prediction with the new network in one single view for the network. So that will allow you to view in 3D the complete network and performance.
All right. Thank you. The next question is for Dean, I guess. What's the role of third-party service providers like neutral hosts for campus networks?
Thanks, Clarisse. It's a good question. I mean, it's gonna vary quite a lot. I mean, the general answer is their role will increase, but I think it's going to vary by country and by the type of industry or the type of site. I think obviously neutral hosts make most sense for those locations where there can reasonably be expected to be a need for multiple service providers. So that tends to be more the visitor or the venue type locations, which could be education, healthcare, residential, hotels and hospitality, obviously notwithstanding the economic and practical issues at the moment. But I think in the medium term, it's going to be those type of places where there can be a good argument run by the landlord to perhaps to capitalize the investment of for the indoor outdoor system but also to think about the environment. So it could be a business park or a new property development or something like that. So I think that we will see a lot of these new models come in. There are some open questions about how things like whether it's roaming, whether it's interconnect, whether it's the localized spectrum, or whether it's just using the existing MNO bands and using one of their signal sources. I think that it's going to be quite exciting to watch.
Right. Thank you, Dean. Mark, does iBwave has a product to design urban small cells?
Good question. This is not part of the use cases that we are targeting with iBwave Reach. So as I said earlier, iBwave Reach is an OEM version of Planet that it's targeting specifically campus environment. So it will be limited to a perimeter or a specific area size. So we are not targeting urban small cells deployments. This would be more done with your typical macro design tool, like Planet, but the others as well.
Okay, thank you. For Dean, I think, what sorts of business models could apply for campuses?
I think I probably covered off that, and actually my last answer was quite long, but yeah, I think it's going to depend on who's leading it, whether it's a specific single mobile operator and what their relationship is with the venue owner. Yeah, because yeah, in some cases, yeah, I hear that the venue is required to pay for the infrastructure. In some cases, service providers deem it worth investing themselves. I think a lot of it's also going to tie in with whether this is linked to the aspirations of service providers to provide more than just the connectivity. So there's a lot of discussion about whether operators, mobile operators, can offer, whether it's industrial, whether they can do more than just smart campus, but they want to have a complete factory automation solution where they're providing the connectivity, edge computing, various the IoT platforms. And I think that's going to be very different to whether it's just a venue that wants to have just a connectivity layer for all of the operators. And I think there's no one size fits all.
Okay. The next question someone is asking for Mark is, can we use same geodata information in both my macro tool and iBwave, like elevation, clutter trees, buildings, etc.?
That's a very good question. So the answer is yes. So if you do have access to geodata already in your company and you're using it for outdoor deployments, yes, you will be able to reuse the same with iBwave Reach. So that's the beauty of the solution. You don't need to acquire new geodata. So for the use cases that we're looking at, what we are suggesting is to use geodata in 3D with 3D model of the environment, including buildings, vegetation, and 2-meter resolution for heights and clutter. Yeah.
All right, thank you. And Dean, can you tell us what the differences will we see between campus networks in different geographic markets?
Okay, so country by country, this is an interesting one because, firstly, we've got very different industrial structures and typical use of office and business parks in different parts of the world. You also will have some of the things I talked about before about the expectations of use and continuity of indoor and outdoor. Clearly, certain types of facility are going to be common, like airports, but when you look at education, when you look at healthcare, you tend to find sort of very different types of property layout in different places, partly down to property prices and general space. What works in Dallas doesn't necessarily apply to London or Singapore, for example. Also, the other side to it is the spectrum policy and the desire and ability for third parties to build local networks and private networks. And if you look at somewhere like Germany, where there's a big push towards industrial campuses with localized ring fence spectrum for like 100 megahertz spectrum for the enterprise. The UK has different policies. CBRS in the US makes a difference as well, although CBRS is interesting because you have both low power and higher power CBSD small cells, so you can actually do the sort of campus-wide environment as well. And that's something I think we'll see some interesting innovation for a number of organizations in the US. So I think there's going to be a fair amount of diversity, and at this stage I would be hesitant to say which is going to be the most sort of interesting or fast to develop.
Clarisse, if I may, there's an interesting question here from the audience.
Go ahead. Yeah, perfect.
Will the macro coverage leak show as 3D view inside the building? So the answer is yes. What I may not have touched enough on my presentation is when you do your prediction in Reach, you have the ability to generate prediction at different heights. Because obviously the impact of the macro network at different height on a building might be very, very different. So you can do as many heights as you want in Reach, and then when you come back to iBwave design, the tool will automatically assign the different prediction maps to the right floors into iBwave. So the results of that is that you'll be able to see in iBwave design the macro penetration at every floor with a different impact based on the configuration of the outdoor environment.
Okay, that's interesting. If you see another questions, yeah, feel free to answer it.
So maybe I can jump in with another one. Do you have any comparison of indoor walk tests and measure penetration compared to prediction in the environment? So basically to check on accuracy. This is a very good question. So so far with our POC results, we have seen very encouraging results. But what we can say obviously is that taking prediction from the macro network will never be as precise as what you can get with the measurements done on site. So so basically you have to take that compromise between quality and cost. So depending on the venue, for VIP venues, you might decide to go and measure directly, but some other venues maybe it might worth taking the prediction instead. So it's really up to the designer to decide if it's worth going on site. So it's another option for you to deliver your project, basically.
Great, thank you. Maybe a last question.
Yeah, I don't actually have access to the Q&A list, so Mark Antoine, you're going to have to have a look and see if there's something else there for me.
Yeah, it's mainly a product question, so I think Mark, if you're able to answer it.
Sure. So the question is if you are using a third-party macro tool, is that a manual step or it can be imported automatically? So so basically there's a few manual steps in the process, yes, but Planet or iBwave Reach has a lot of capabilities to import CSV tables very easily in the tool, so that process is not that complicated to use and provide big advantage once you do it.
All right, so thank you very much. I think we're gonna end it here. So thank you, Dean, for your presentation, and Marc Antoine, and thank you to our attendees for joining us today. So as Dean mentioned, we also have a great ebook on Campus Network, which you can download on our website. So thank you, everyone. Stay safe, and we hope to see you at the next webinar.
Thank you.
Thank you. Bye-bye.
Thank you. Bye-bye.